What we at? We're doing Wreath. We are. Let's post the link so everyone can see. This is the room. So yeah, what Wreath teaches you is how to pivot through a compromised network. So we've in the other sessions that we've done, we've breached the first one, learnt to pivot on this box, which allowed us to gain. So these bottom two Windows machines are on an internal network, so you can't access them without pivoting through this original prod serve. So we pivot on this, access the next box, scan for vulnerabilities, and then we found another one. This is why we've got like the lightning bolt effect around it, means that we've got like root on there. And then now we can finally contact this final machine, which is a nice little web service. So if we scroll down all the millions of tasks that we've done, just want to show you. So we've got, like, it's just my local box. Then .200 is the first box. So we've got a root, like SSH certificate on there, so we can just connect on. Also running SSH shuttle from my local machine, but what this is doing is it's connecting to that root on the prod serve, and then it's basically taking any connection I make to this subdomain, so the 10, 29 or 90, and then any subdomain, and then shoving it through this box, which then allows me to find this box. So then this box we ended up with an administrator hash, so we can use a pass the hash to get access to the admin credential or the admin access on the box. And then we've just been sort of looking around some of the files on here, but this one's also running a chisel service. So chisel was one of the other techniques we learned. And then again on my box here, we've got the chisel client running. So we're chiseling out through SSH shuttle onto the chisel service, which then lets us sort of look around beyond that second machine into the third machine. So with that answered, we need to go on to our middle box. And then I already answered it. I was trying to look around once I fixed all the proxies within proxies and all that nonsense. So one thing I found was just, if we go to the root, then there's a folder called git stack. So we do git stack. Have a look in there. And then there's a folder called repositories. And then that's where we found the website.git. So I posted that in there, and then used evil winrm to download it. So it's literally just wrong window. Download, and you have to put the full like C address in here. Repositories. What is it? Website. .git. And then we put our local directory, so home, Cali, documents, THM, Wreath. And then I'm not going to do it because I've already done it, but it takes a little while to do as well, so that's why I did it first. So we go to THM, Wreath, and then we got the website.git. And then this originally had like a load of files in it, but if we open a terminal to there, so cd website git. So although you can't see anything, if we do an ls la, you'll see there's a .git. So we renamed that folder .git, which then hides it from the menu, but then we can cd.git. And then there's all the files in there, so we can do ls la again. So there's all the git configuration files all ready to go. So Cool, so then we can exit out of evil WinRM. You should see the new directory, which we did. We renamed it, so we can do this task. And then a bit of explanation on Git repositories. They always contain a special directory called .git, which contains all the meta information for the repository. The directories can be used to fully recreate a readable copy of the repository, including things like the version control and branches. If the repository is local, then this directory would be part of a full repository, the rest of which would be the items of the repository in a human readable format. However, as the Git directory is enough to recreate the repository in its entirety, the server doesn't need to store this easily readable versions of the files. This means that what we've downloaded isn't actually the full repo, so much as it is the building blocks we can use to recreate the repo, which is actually what happens when we use git clone to create a local copy of the repository. So in order to extract the information from the repository, we'll use a suite of tools called git tools. So we need to clone the repositories into the current directory using git clone. So do we want to go into the current one? Guess so. Let's just do it here. Git clone. Actually, it doesn't say to go into the git, does it? So just said to rename it, so you could probably go up one. Yes, let's rm rf tools. Let's go up, and then we'll do the git clone again from here. Right. So, Git Tools repository contains 3 tools. The dumper, which can be used to download and expose Git directory from a website should the owner of the site have forgotten to delete it. Extractor, which can be used to take a local Git directory, recreate the repository in a readable format. This is designed to work in conjunction with the dumper, but will also work on the repository that we stole from the Git server. Unfortunately for us, while Extractor will give us each commit in a readable format, it will not sort the commits by date. Finder can be then used to search the internet for sites with exposed Git directories. This is significantly less useful to an ethical hacker, although it has applications in bug bounty programs. So let's use the extractor to obtain the readable format of the repository. So let's do I guess we need to go into it. cd git tools. There's extractor. So there's extractor. So we /extractor shell. The repo dir will be the directory containing the .git directory for the repository. Note that this is not the .git directory itself. It looks for the .git directory inside the specified directory, which is why we had to change the original name of the directory to .git. Right. So we can say for example, if we closed, it's slightly confusing, so I'll explain each option. Repo dir is the directory containing the .git directory. Destination dir is the subdirectory into which the repository will be created. So for example, if we cloned Git tools repo into the same directory as .git, which is what we just did, we downloaded the Git server, we can then extract the contents of the stolen repository into a subdirectory called website. So actually, if we go up a directory, again, so now we're here. So now we can do Git tools, extractor shell in the local directory. Call it. Let's keep it the same website. And we have a new folder called website. Create the repository, recreate the repository, and we'll perform some code analysis in the next task. Let's head into the newly created repository and we'll see 3 directories. So cd website. Each of these corresponds to a commit. However, as previously mentioned, they are not sorted by date. It's up to us to piece together the order of the commits. Unfortunately, there are only 3 commits in the repository. Each has a commit meta text file which we can use to get an idea of the order. We could just cat each of these out separately, but we may as well do it the fancy way with a bash one-liner. Let's take that bad boy. This gives us the 3 commit metas in a nicely formatted order. Although mine are in a different order, weird. So we get update the filter, commit to backend, website commit. Note that the number at the start of these directories is arbitrary and depends on the order in which Git tools extracts the directories. Okay. What matters is the hash at the end of the file name. Logically speaking, we can guess that these are currently in reverse order based on the commit message. However, we could also check the parent value of each commit, starting at the only commit without a parent, which must be the initial commit. We can then work down the tree in stages like so. So I think this has actually reversed it since they've done it before. So you have static commit at the top. Guess. Yeah, there's no parent. So we take the 70DD, which goes into this one. Then it goes 82DF. Theo! Why did I not get an alert for that?
Follow.
There we go, I've muted it. Theo, how you doing, mate?
Getting worse and worse. I'm gonna stop this.
Why is the stream of the stream faster law?
And I think my laptop is pretty much dying now.
We gotta clip that. That was hilarious. How do I clip that? Wait, where am I? How do I clip that?
Okay, like I said.
Where's my...
It's just Lucaception. Just endless Luca. Alright, there we go. So yeah, we're just looking at some Git history. So I should probably explain what the whole point of this lab is.
Theo says, Riff-raff inbound.
Riff-raff inbound.
Hi, AdamSec.
So yeah, the whole point of Wreath is that it teaches you how to do network pivoting. So a lot of the CTFs, you'll only compromise one box. This first box is the one that you start on with the penguin. There is a webmin exploit on there that you get root through, and then you can use this box to pivot through, and then the final 2 Windows boxes are on an internal network. So if you're outside of the network, imagine there's like a 4th box up here, you can't connect to any of these Windows boxes. So in order to do that, we set up a SSH shuttle, which connects to this first box through SSH, and then it forwards any connections that we want through to the next network. So here we've got like a subdomain that's just saying like anything that isn't, or that is going to that address, that it will just forward it on. And then that lets us use this tool, so we can now finally talk to that middle box. So we found another vulnerability. We uploaded a web shell. That web shell then gets us access to the like we can dig around. I think we found an admin hash, which you can then use this tool to log in with that admin hash. And then once that's done, you can then pivot again into this final one, which is just running this website at the moment. But before we're going on, this final bit of the task is just sort of getting us to dig around on that middle box, because there's this Git repository that we want to now. Well, what we've just done is sort of extracted a remote copy of a repository into a local one that we can now sort of dig into. So if you aren't aware of what repositories look like, so this is a commit. So this is an instance of a developer saying, right, here's a chunk of code that I'm committing. And then in this case, he's got 3 commits. So there's 3 separate instances of code being committed into this repository. And then this one here is the first one. So the first instance of him doing that, there's no parent because it's the first one. And we're just following the hashes. So this commit has a hash to identify itself. And then we can map that onto its parent of the next commit. And then this hash maps to the parent of the next commit. So we know what order they come in. And then I'm not sure what the relevance of this is yet, but we're getting to that in the next bit. So we know what order they come in. We could do this by also checking the timestamps attached to the commits, which are in Unix format. Okay, yeah, we don't need to do that. So then the short version is the most up-to-date version of the Git stored in the repository is that one. So let's take a copy. So then that's the latest hash. So what's it going to get us to do now? Oh, we've got no music. Let's sort that out. Right, so head into that directory. So we need to go back onto here. So we've got some files in there. The index.html file isn't promising. Realistically, we need some PHP, which we identified as the web server's backend. Let's look for PHP files using the find command. So find current directory, name, anything ending in PHP. There's only one result, the resources index PHP file. So if we go I guess we've got to go into resources and then we can cat. So we've got, it's like some file upload. Read through the file. What does Thomas have to phone Miss Walker about? Phone Miss Walker about the network, the neighborhood watch meeting. I guess it just wants to be that, doesn't it? This appears to be a file upload point, so we might have the opportunity for a filter bypass. Additionally, the to-do list at the bottom of the page does not only gives us an insight into Thomas's upcoming schedule, also gives us an idea about the protections around the page itself. Aside from the filter, what protection method is likely to be in place to prevent people from accessing this page? So, get Ruby more food, okay, Fomus Walker. Upgrade the filter on this page, you can't rely on basic auth for everything. So I'm guessing they're just going to have like some like login check, like is... basic, well, I'm not even seeing any usage of the auth. Point 3 in the to-do list. Face. Is that it? Just basic auth? Okay. I thought there'd actually be like some use of it. No. Okay, let's turn our attention to the code itself. Reading through the PHP code, it appears that there are two filters in place, plus a simple check to see if the file already exists. The first line here uses the classic PHP technique to see if a file is an image. So get image size. In short, the images have their dimensions encoded in EXIF data. The getImageSize method returns these dimensions if the file is genuinely an image, or if the Boolean value is false if it is not an image. This is more difficult to bypass than other filters, but far from impossible to do so. The second line is an if statement, which checks two conditions. If either condition fails, indicated by the OR operator, the script will redirect with a failure message. The second condition is easy. The size just checks to see if the size contains the Boolean false. The first condition may need to be broken down a little bit. So, actually I can highlight it on this one. Let's go. It's uploaded, temp name. To this bit. So there are two functions in play here, the inArray and Explode. Let's start with the innermost function and work our way out. So Explode is used to split a string at the specified character. Here it's being used to split the name of the file that we uploaded at each period. From this we can rightly assume that this is a file extension filter. As the example, if we were to upload a file called image.jpg, this function would return a list of image.jpg. As the filter only really needs the file extension, it then grabs the second item from the list, remembering that the list starts at 0. This unfortunately leads to a big problem. What happens if there's more than one extension? So if we upload a file called image.jpg.php, the file name gets split into image.jpg.php, but only the JPEG gets passed into the filter. So looking at the outer function and replacing the inner function with the placeholder of explode results. So in array, the result of explode we check that it is not in the array called good extensions. In other words, this is a whitelist approach where only certain extensions are accepted. So which extensions are accepted, comma separated, no spaces or quotes. So there we go. Just take my quotes out. No spaces as well. Yeah. Cool. So we know that we need to name whatever file we upload as .jpeg, whatever we want, and we can bypass it. We'll see if we see that the file will get moved into an uploads directory with its original name, assuming it has passed the two filters. So we know how to find our uploaded file. There are two upload filters to bypass, and both of them are bypassable. So let's build our park. We know what's likely to happen when we access this page. It will probably ask us for credentials. We'll be able to upload files, image files. There are two filters in play to stop us from uploading other kinds of files. Both of them can be bypassed. So let's head for the resources directory. So let's chuck this on the right side, or the left side. Something a bit more upbeat. Come on! This thing's... Let's just check the network hasn't died again. Extend it another hour as well while we're here. So it's still running, that's good. Why aren't we accessing it? So as we're connected, still listening. Let's try it through proxy. Did I change the port? Yes, I did. SOX 5 is not enabled. Should be. Pretty sure I did it through SOX 5.
Sound Alerts says.
Mellow 1892 played Hello Mother for 0 bits.
Why didn't that work? That should have played something.
Melorino says.
Well,
Veil. Hello.
let's try that again. I turned it all off the other day because we got like follow botted. Let's see, where's the thing? Did it?
Sound Alerts says.
Zach played Hello Mother for 0 bits.
Well, that's good. Doesn't play anything. Refresh the cache.
Melorino.
Hello, motherfucker!
Hello, motherfucker. There we go. Fixed. Thank you, Dreamer C, for the follow as well. I've just seen that. Right, why aren't you working, you bastard? SOX 5 is not enabled. Pretty sure it was. Chisel server SOX. Yeah, let's turn it off there. Here's to
Thank you for the follow.
Thank you for the follow, Maggio68. We just need to do this again. Just do. And so. Didn't like that. Oh yeah, wrong directory. Go to the temp folder, and then we can run it. So now we're listening on SOC 5. Let's do that again, SOCs. And let's refresh you. That's better, cool. Fixed. Lots of fixes today. We don't know what the password is, so admin. So we can assume that the username is probably either Thomas or Wreath, both of which we've already seen. Yeah, I don't remember that, but we probably already have one of Thomas's passwords stolen from the Git server using Mimikatz. That's right, we did. Let's have a look. That's admin. User Thomas. Got his hash. See if you can log in with these usernames and passwords. So we know it's... What's that called? Let's get over here. We know it's Thomas. Let's see if we can get your hash easily. Crack station. Let's do the I'm not a robot. Oh yeah, that was it. I Heart Ruby. Completely forgot that we got that earlier. We definitely got that somewhere. Just didn't save it. Alright, so Thomas. Let's turn you back on. So I Heart Ruby. I'm in. Right. Next, what's next? We can log in. Have you done that one? Yeah. So how cute. A page that will allow Thomas to upload pictures of his beloved cat Ruby. Try uploading a legitimate image, see if you can access it. Steal that one. Upload. So files uploaded. Let's uploads. Let's upload. So I just did uploads again. did it upload to? Let's have a look. Yeah, upload. Oh yeah, is it just not searchable? Random. Right, maybe it just doesn't do the directory listing. So let's try. No. Is it? Okay, cool. So you need the resources in there. And it's not traversable. Cool. Okay, so I can access the picture. I can. So we know how to bypass it. Simply change the extension to .php. The second filter is slightly harder but doable, as getImageSize function checks the attributes that only an image will have. So we're going to have some other tool. Yeah, there we go, Exif tool. So we need to upload a genuine image that contains a PHP web shell. If this file has a PHP file extension, it will get executed by the website as a PHP file. Meaning all we need to do is force a web shell into the file and we're golden. The easiest way to stick the shell in is the exif data for the image, specifically in the comment field to keep it nicely out of the way. Take a regular image and rename it to... Okay, let's do that. Let's keep our dodgy one. I'm just going to copy it so we've got a duplicate to work with. And then we're going to go .php, and I need to prefix it with my username for this. So test msec png. They're using a JPEG, but it's probably fine. Got Exif installed, Exif tool, yeah we do. Test mpeg. So that's the data stored in the image. So here we can see all the Exif data. It also allows us to edit this information before we actually start inserting payloads into the image. There's one more thing to take into account. There is antivirus software running on this target, and we don't know which AV Thomas uses. But we know that there will be protections enabled on the target. We don't know how strict the antivirus is. For all we know, it could pick up any kind of default PHP web shell, which would then alert him to how close we are to compromising his host. It might not, but why take the risk? For this reason, we will not be uploading a live payload in this task. Instead, we'll create a proof of concept here, and then upload a live payload when we complete the PHP obfuscation task. So let's create our POC. We'll be using the following PHP payload for this, so let's copy that. save it. So we go, let's stick it in Wreath. Pook. There we go. Alright, this is completely harmless and ergo should not be picked up by AV. It does give us confirmation that this is likely to work, however, and stages the way for the actual web shell payload. So if we add this image, add this to our image using Exif tool. So I didn't need a new text file, let's just do Exif tool. I need to start with the comment equals in quotes and then paste it in. No such. Okay, why didn't that work? Oh, we need to do the backticks in the right place. That's better. Alright, now if we try to upload this file and access it, what do we get? So we go back to Ruby, browse. Let's do all files. So that uploaded. Test msec png.php. Cool, so we see our payload run. Note that the HTML form is configured to only allow image uploads through the GUI, so don't be alarmed if you want. Oh yeah, we didn't figure that out. We will have the ability to execute arbitrary PHP. Yeah, okay. AV evasion. So Antivirus Evasion is the third and final primary teaching point of the Wreath network. By nature, AV evasion is a rapidly changing topic. It's constant dance between hackers and developers. Every time the developer releases a new feature, the hackers develop a way around it. Every time the hackers bypass a feature, the developers release another feature to close the exploit, and so the cycle continues. Due to the speed of the process, it's nigh impossible to teach bleeding edge techniques and expect them to stay relevant for any length of time. So we're going to cover the fundamentals of the topic here. Without further ado, let's dive in. When it comes to AV evasion, we have two primary types, on disk and in memory. On disk is when we try to get a file saved to the target, then executed. This is very common when working with executables. In memory is when we try to import a script directly into memory and execute it there. For example, this could mean downloading a PowerShell module from the internet of our own device and directly importing it without saving it to the disk. In ages past, in-memory evasion was thought to bypass most AV, as the majority of antivirus was unable to scan scripts in memory. This is no longer the case, as Microsoft implemented a feature called Anti-Malware Scan Interface, AMSI. AMSI is essentially a Windows feature, or a feature of Windows that scans scripts.
Thank you for the follow.
Thank you for the follow to T-Bit. Tell me how to pronounce your names. Yeah, so we can. Where was I? We can scan the script as they enter memory. It doesn't actually check the script itself, but it provides a hook for the AV publisher to use. Essentially, it allows an existing antivirus software to obtain a copy of the script being executed, scan it, and then decide whether or not it's safe to execute. While there are various bypasses for this, often involving tricking the AMSI into failing to load. These are out of scope for the room. In terms of methodology, ideally speaking, we would start by attempting to fingerprint the AV on the target, get an idea of what we're up against. As this is often an interactive, social engineering reliant process, we'll skip it for now and assume that the target is running on the default Windows Defender. So that we can get straight into the meat of the topic, if we already have a shell on the target, we may also be able to use programs such as Sharp EDR Checker and Seatbelt to identify the AV solution installed. Once we know the OS and the AV, we would then attempt to replicate the environment in a virtual machine which we can then use to test the payloads against. Note that we should always disable any kind of cloud-based protection in the AV settings, potentially by outright disconnecting the VM from the internet, so that the AV doesn't upload our carefully crafted payload to the server for analysis, destroying all of our hard work. Once we have a working payload, we can then deploy it against the target. AV evasion usually involves some form of obfuscation when it comes to the payload. This could mean anything from moving things around in the exploit, changing the names of variables, encoding aspects of the scripts, to outright encrypting the payload and writing a wrapper to decrypt and execute the code section by section. This aims to switch things enough that the AV software is unable to detect anything bad. So which category of evasion covers uploading a file to storage on the target before executing it? That is on disk. Submitted. Oh yeah, we're chiseling. Turn it off. There we go. And let's check I've got time. Right, what does AMSI stand for? It was something script interface. Anti-malware scan interface, there we go. Which category of evasion does AMSI affect in memory? Right. Why did that not complete? Completed. Did I skip something? Yes. There we go, I missed that one, and I missed that one. Right, detection methods. Before we get into the practical side, let's talk a little bit about different detection methods. Generally speaking, detection methods can be classified as either static detection or dynamic heuristic behavioral detection. Modern antivirus software will usually rely on a combination of these. Static detection usually involves some kind of signature-based detection. A very rudimentary system, for example, would be taking a hash sum of the file, comparing it against a database of known hash sums. This system does tend to be used, however, it would never be used in itself in a modern antivirus solution. For this reason, it's a good idea to change something when working with a known exploit. The smallest change will result in a different hash sum, so even something as small as changing a string in the help message would be enough to bypass this kind of detection. Fortunately or unfortunately for us as hackers, there is usually nowhere near enough to bypass static detection methods. That doesn't make sense. This is usually nowhere near enough to bypass static detection. The other form of static detection is often used in antivirus software to much greater effect as a technique called byte or string matching. Byte matching is another form of signature detection which works on searching for the program looking to match sequences of bytes against known database of bad byte sequences. This is much more effective than just hashing the whole file. Of course, it also means that we have a much harder job of tracking down the exact line of code responsible for setting off the flag. The trade-off with this method, of course, is speed. Checking small sequences of bytes against a potentially huge problem with multiple libraries can take comparatively long time compared to the milliseconds it would take to hash the entire file. As such, a compromise is sometimes where AV will hash small sections of the file to check against the database rather than hashing the entire thing. This obviously reduces the effectiveness of the technique, but it does increase the speed somewhat. Where static malware detection methods look at the file itself, dynamic methods look at the ACKs. There are a couple ways to do this. So AV can go through the executable line by line, checking the flow of execution based on defined rules to see what type of action is malicious. It could be reaching out to a known bad website, messing with values in registry, The AV can see how the program intends to act and makes decisions accordingly. Suspicious software can outright be executed inside a sandbox environment under close supervision from the AV software. If the program acts maliciously, then it gets quarantined and flagged as malware. Evading these measures is still possible, although a lot harder than evading static detection. Sandboxes tend to be relatively distinctive, so we just need to look for various system values. Is there a fan installed? Is there a GUI? And so on. If so, what resolution is it? Are there any distinctive tools for services running VM tools, for VMware virtual machines, for example? We can check to see if there are any red flags, for example, a machine with no fan, no GUI, and a classic VM service is likely to be a sandbox. In this case, the program should just exit. If the program exits without doing anything malicious, then the AV software is fooled into believing that it's safe and allows it to be executed. Equally with logic flow analysis, the AV software is only working with a set of rules to check malicious behavior. If the malware acts in a way that is unexpected, e.g. it has some random code that does a grand sum of nothing inserted into the exploit, it's likely to pass the detection method. In addition to this, when working with certain kinds of delivery methods, password protecting the file can get straight around the behavioral analytics check. As usual, and as unlike the user who knows the password, an AV software is unable to open and execute the file. So, static detection methods are usually a lot more effective. Dynamic detection are usually a lot more effective than static. The drawback is once again that time and resources are required to spin up a VM, to analyse the file in and go through it line by line, see what it's doing. These are actions that take time, causing users to grow impatient and use up a lot of the computer's resources. Once again, AV has to compromise using a combination of dynamic and static analysis. To make life harder still, antivirus vendors are usually in close contact with one another, as well as with scanning sites like VirusTotal. When an AV detects a suspicious file, it usually sends that file to servers owned by providers, where it can get analysed and shared with other providers. What this means is that once our payload is detected on one machine, chances are it will be likely taken apart and shielded against. The rapid sharing of information allows AV providers to stay ahead of bad actors, which is a good thing. It also obviously adds an extra complication to our job as ethical hackers. Additionally, new techniques are being developed all the time. For example, many attempts are being made to use machine learning techniques to dynamically update the list of bad behaviours in a sandbox, or the rule list used in low logic flow analysis of a suspicious file. If you're interested in some of the work being done in this area, try out CMnatic's dissertation on the subject, which can be read here. We'll do that later on. So, what other name can be used for dynamic heuristic detection? What's the word they're going to be after? Behavioural. If AV software splits a program into small chunks and hashes them, checking the results against a database, this is static or dynamic. Static. When dynamically analysing a suspicious file using a line-by-line analysis, what would antivirus check to see if the behaviour is malicious? It's going to be what, intent? Or what do they say? Predefined rules, there we go. I hate these ones where it's just like, find the random bit of text that we're on about. What could be added to a file to ensure that only a user can open it? Running AVs. Encryption. Passphrase, something. password protecting. There we go. Which means fucking encrypting it. So right, now that we've covered the basic terminology, let's get back to hacking this PC. We have an upload point which we can use to upload PHP scripts. We now need to figure out how to make the PHP script that will bypass the AV. Windows Defender is free and comes pre-installed with the server, so let's assume that that's what's being used. The solution is this: we build a payload that does what we need it to do, preferably in a slightly less than common way. Then we obfuscate it either manually or by using one of the many tools online. So let's build the first payload. I can finally use my file. So get Wreath is set cmd, and then execute the shell. Here we check to see if it has a Wreath parameter. If so, we'll execute it using shell exec, wrapped inside pre-tags to give us a clean output, and then use die to prevent the rest of the image from being shown as garbled text. This is slightly longer than the classic PHP one-liner, for two reasons: because we're obfuscating it, and it will become a one-liner anyway. Anything different is good when it comes to AV evasion. Now we need to obfuscate this payload. There's a variety of measures we could take, including but not limited to switching parts of the exploit around so they're in an unusual order, encoding all the strings so that they're not recognizable, splitting up the distinctive parts of the code. Manual obfuscation is very much a thing, so for the sake of simplicity, let's just use one of the available tools. The tool linked here is recommended. When it comes to web obfuscation, these tools are generally used to make the code difficult for humans to read. However, by doing things like obfuscating variable function names and encoding strings, they also prove effective against antivirus. So stick the payload into the tool. Okay, so we've just got a PHP obfuscator. You don't need the here bit, do you? Add our own bit of custom nonsense to it. Right, and then what we're going to do, absolutely everything. So tick tick. I'm going to rename prefix length MD5 length. Okay, so that's all legit. Click on the obfuscate source code button and we'll get left with this mess of PHP. An advert. Right, there we go. So that's our encoded version. As this is getting passed into a bash command, we need to escape the dollar signs to prevent them from being interpreted as bash variables. So doesn't look like there's many, so just that's it. With any obfuscated payload, we can now finalize our exploit. Once again, make a copy of the innocent image, ensuring that you give it a name. So this one needs to be shell, so let's duplicate that one again. Ditch the original, ditch the copy, and then this one is shell. So this time we'll get rid of all this. Looks good. Oh, I fucking put it in the wrong file. That's why. Right, shell. Right, let's fix the other one. So that should be test. So. Right, so we've got the shell and the test. Where's my music starts? So we've done that. Upload your shell and attempt to access it. If it works, you should get an output similar to the following. Just add this to my notes quick. Oh fuck. We go from close tab. So this one will be shell msec, and then I haven't uploaded it yet, so let's do that. And we need our SOCAT or chisel active, so let's upload. Uploaded successfully, and wow. Cool, so we get that. Right, so now we can execute commands using the Wreath get parameter. So let's dump that in as well. Ta-da! So what are we looking for? What is the host name of the target? Wreath-PC. What is our current username? Include the domain in this list. You have to do a Wreath PC Thomas. I thought I set the patterns up on this, so it should work. need to add like another one that's like any other thing. Got used to bloody changing it every 5 seconds. Right, so we can run stuff. Let's do something a bit more naughty. Compiling Netcat and reverse shell. Fortunately, we have a problem. Unlike in Linux, where there are usually many ways to obtain a reverse shell, the options in Windows are a lot fewer in number, as Windows tends to not have many scripting languages installed. Realistically though, we have several options here. PowerShell tends to be a good go-to for Windows reverse shells. Unfortunately, the defender knows exactly interpreter. Windows PHP reverse shells tend to be iffy though. Again, this may trigger defender. We could generate an executable reverse shell using VS Venom. Oh, MSF Venom, not VS Venom. Then upload and activate it using the web shell. Again, MSF Venom shells tend to be very distinctive. We could use the Veil framework to give us an interpreter shell executable that might bypass defender. But let's try and keep this manual for the time. Equally, Shelter, although old, might give us what we need. There are easier options though. We could upload Netcat. This is a quick and easy option. The only problem with uploading Netcat is that there are hundreds of different variants. The version of Netcat for Windows that comes with Kali Linux is known to Defender, so we're going to need another version. Unfortunately, there are many floating around. Let's use one from GitHub. So we need to clone a directory. Clear. Let's just dump it here again. Unless got tools on my CD. Tools ls. Windows. Let's stick it there. Let's move Netcat. So I'm not going to mess with the other one. So actually, let me just paste that, can't I? So, cloning into Netcat.exe. So this contains a pre-compiled binary for Netcat, both 32 and 64. However, it's an ideal time to talk about cross-compilation techniques. If you prefer to use the default binaries, then just skip ahead to the last section of the task and use the NCAT 64. Cross-compilation is an essential skill, though in many ways it's preferable to avoid it. First up, what is cross-compilation? The idea is to compile the source code into a working program to run on different platforms. In other words, cross-compilation would allow us to compile a program for Linux, different for Linux version, and the Windows program on Kali, as what we're doing here. Or even software for an embedded device or phone. While cross-compilation is a very useful skill to have, it's often difficult to get completely correct. Ideally, we should always try to compile our code in an environment as close to the target environment as possible. For example, if we exploit or program, if our exploit or program is designed to work on CentOS 7.2, we should try to compile it in CentOS 7.2 VM if possible. Equally, it's essential that we get the same architecture as the target. 64-bit program won't work very well on a 32-bit target. Sometimes it's easiest just to cross-compile, however. generally speaking, we cross-compile x64 Windows programs on Kali using the Ming ww64 package. This is not installed on Kali by default, however it is available in the Kali apt repository. So let's grab that. I think I might already have this from doing some other compilation. No, maybe not. This is a big package, but once it's installed we can start recompiling Netcat. Much like when we used GCC to compile binaries on Linux, we can use MingW compilers to compile Windows binaries. These tend to have very descriptive read-long names, but the one that's of particular importance to us here is x86, 64, w64, Ming32, GCC. This specifies what we want to compile as a 64-bit binary. Inside the NC.exe repository, delete or move the two pre-compiled Netcat binaries. So we need to... I'm going to just do what I did with the other one, so move. You can be an old one, and then what's the other one, NC64. Yeah, be an old one. So now we can go. Provides a makefile which we can use with some small alterations to compile the binary. Open up the makefile with your favourite text editor. Nano for the win. So we can see the first two lines specify which compiler to use. Neither of these are quite what we're looking for, so comment out the first line. Add in cc equals x86 64 w64 w32 gcc. So the only difference is that PC got changed to a w64. Okay, so we'll save that. Now when we run make, which I didn't like, no such file or directory. What have I fucked up there? There's no underscore there. It's better? Right. So that's compiled. This will generate a new 64 Windows executable. Note that there will be lots of warnings generated. These have been redirected to dev null. However, you do not need to do this. There are nothing to worry about here. Just so we do ls. We got a new nc.exe. Follow the steps detailed and compile a copy of Netcat. Otherwise, use the copy already in the repo. Yeah. Do it the hard way, baby, and then with a copy of Netcat available, we now need to get it to the target. Start sudo, start a web server, so Python web server. Numerous times already. Despite it often being much harder to upload binaries to Windows than it is to upload to Linux, we do have a few options here. PowerShell might work. Hey, Producer Wolf. We could use the file upload point that we originally exploited to upload an unrestricted PHP file uploader in the same way that we uploaded the original web shell, although this would be a bit of a pain.
Missed the stream again.
No, well, I'll be saving the VOD, don't worry, so you can watch again. Yeah, all the VODs actually are stored, so you can go through the Wreath part 1. This will be part 5. Most of it's just me getting frustrated at things not working or me doing it wrong. But yeah, I'll probably actually will condense them into like a set of not me fucking burning my hair off. So yeah, it'll just be like the actual things that you need to do to complete it. So now that we could add an upload point.
I also meant B730S stream.
Oh no. Could look for the other command line tools installed on the target, such as curl, certutil. Both allow file upload. Try to execute both of this in the web shell. Both should work. Do you mean the curl or certutil ones, I guess? So let's do. I don't know if this will connect back to me if I've got to go to upload it to the other machines. 10, 15, 19, 1, 17. Chisel again. It looked like it did something. We got it. Yeah, we got the get. So yeah, it did reach out. Let's do it again with certutil. This has like a funny way of doing it. I can't remember what the thing is. Oh yeah, fucking turn the proxy off. GTFO bins as its lol bins. Lol. So this has the file upload method in it. Or download, I should say. Yeah, download. So URL cache split. That's what we want. So we need to stick in URL cache split, where the location is, and then nc dot. Didn't fetch it again, did it? Oh, I'm not running it in the proxy, that's why. Let's change this as well. So we'll name it certutil, just so I know which one it was. So let's stop that request. Turn the proxy on. Unable to execute certutil. Okay. That's because it didn't work. It doesn't have it on.
Nightbot says.
You can change your TDS voice here. Web link.
You can. What output do you get when running the command certutil.exe, such as on its own? dump commands completed it. So instead we'll stick with trusty old curl. So it doesn't want me to do it that way then, I guess. So just says unable to execute, so I'm wondering if they must block it, like it says. Get my curl command back. Right, so that kind of works. So we need to actually run it with the output to stick it in the temp there. So let's give it the msec prefix. Right, cool, and then now we have everything we need to get reverse shell back from the target, because we can just run. Set up a Netcat listener on your attacking machine, then in your web shell use the following command. So there's our Netcat listener, then we can just go stick these in as well. So I've got, so the Netcat is going to be my one I compiled, attacker IP is going to be 10.50.91.172 4444. Copy that first as well. Yeah, I did. Upload. So upload the Netcat to Freelance. Stick that in there. Copy of it as well. And and hope for the best. Hey! Done that. Done that. In order for this to work, I had to wrap the netcat command inside a PowerShell process to keep it from exiting early. Bonus question. Try generating a Metasploit reverse shell and transfer it to the target. Is that really needed? Metasploit. So this will just be reverse TCP shell exe attacking IP 10.50.91.172. Should we do for port? Just 5555 shell. Sec. Make sure you place it in a directory that you can list, e.g. the uploads directory of the web server. The shell will get picked up by Defender, so don't do it anywhere else. It will give you a feel for how antivirus operates when it detects your payload as being malicious. So let's start the web service again. What was this one called? What do we call it? MSF Venom Shell MSF.exe. Oh yeah, and proxy. Looks like it ran it alright. Saying that we didn't do the output, did we? Stop snapping. Okay. Shield, shell, MSF Venom. Then we just want to do don't need to do that, do you? Because it won't connect back. You should get an error message when trying to execute the executor, as the exe will also disappear from the target directory as placed by warranting an AV. So we won't run it, we'll leave it there. So, enumeration, what we're going to do now that we know where we've got the reverse shell. We have the reverse shell on the third and final target. This is cause for celebration. We don't yet have a full system access to the target though, as we saw when we first obtained the web shell. It is unfortunately not running with system permission, contrary to the XAMPP defaults. This leaves us with a low privileged account. Looks like Thomas was sensible in his security on his own PC. This does mean that we're going to need to enumerate the targets for privex vectors. With Defender active, we'll have to do it quietly. Let's consider our options. We could and should always start with a little manual enumeration. This will be relatively quiet and gives us a baseline to work with. Defender would definitely catch a regular copy of WinPs. However, it would be unlikely to catch either the BAT version or the obfuscated EXE version, both of which are released in the Ps repository alongside the regular version. Chances are that AMSI will alert Defender if we try to load any PowerShell privisk script checks. So ideally we should be looking for obfuscated versions of these if we were to use them. Let's start with some manual enumeration. Hopefully we come up with something workable. Use the command whoami-priv. We did whoami, let's do whoami-priv. One of the privileges on this list is very famous for being used for the print spoofer and potato series of privilege escalation exploits. Which privilege is this? So let's just save this to my notes quick. No, I don't know the answer to this, but I'm guessing it's going to be the longer of them. No. Create global privilege, that looks pretty bad. No. Impersonate. Hey, cool, there we go. So, our current user, our current user likely has the privilege due to running XAMPP as a service on the account. Unfortunately, this also means that XAMPP won't be a good privex vector in its own right, but we might need to use the privileges that it's given us. We now use whoami groups. There we go, I'm just going to save that. So if we check the users groups, unfortunately the account isn't in the local admin group. Combined with the high integrity process that we're currently using, which would make any further privilege escalation redundant. Now that we've got an idea of our own users' capabilities, let's look at the box itself. Windows services are commonly vulnerable to various attacks, so we'll start there. Generally speaking, it's unlikely that the core Windows services will be vulnerable to anything. User-installed services are far more likely to have holes in them. Let's start by looking for non-default services. Just the group info, that's the bit I want. So this lists all the services on the system, then filters out so that only the services that are not within the Windows directory are returned. This should cut out most of the core Windows services, which are unlikely to be vulnerable to this kind of vulnerability, leaving us with primarily the lesser known user-installed services. There should be a bunch of results returned here. Read through them, paying particular attention to the path name column. Notice that one of the paths does not have quotation marks around it. So that's just a bit awful to look at it like that, isn't it? Let's go full screen. Run it again. What's that like? It's better. So path name does not have quotes, there we go, so it's System Explorer Service. What is the name, second column of this service? There we go, so System Explorer Help Service. The lack of quotation marks around the service path indicates that it might be vulnerable to an unquoted service path attack. In short, if any directories in that path contain spaces, which several do, and a writable, which we're about to check, then assuming the service is running as the NT Authority System account, we might be able to elevate privileges. First of all, let's check to see if which account the service runs under. So let's check this back on the left. So SC QC service name. So is this service running as local system account? It is. So this is looking good. Let's check if the permissions on the directory that we can write to, if they are, then we're golden.
Ted_918 says,
Hey Ted, how you doing? So we need PowerShell path, System Explorer. So what does this get us? So we can see built-in allows full control. So we have full control over the directory. How strange, but hey, Thomas's security oversight will allow us to root the target. In the interest of learning, it should be noticed here that this is far from the only vulnerability by the looks of things. Thomas has installed the program but couldn't be bothered entering the password for the administrator account every time he needed to interact with it. As a result, he botched the permissions and gave every user access to this aspect of the program. This means that we can create our unquoted service path exploit, but we would also perform attacks such as DLL hijacking or even outright replacing the service executable with a malicious binary. That said, we'll stick to the unquoted service path vulnerability to avoid messing with the service itself. This way all we need to do is create our own binary and then delete it, rather than alter any of the files in the service itself. Try to get a copy of WinPs to... Oh, okay, yeah, we're not going to do that. You will see that there are many more potential vulnerabilities on this target. Anyone want to see WinPs? I'll do it if there's interest. So yeah, we just need to download that. Go once, twice. No. Alright, we'll carry on. Let's get this run done. Alright, PrivES. Let's recap what we found. So we have a privilege that we can get escalation. Downside is that we need to obfuscate the exploit in order to get to run past Defender. We have an unquoted service path vulnerability for a service that is running a system. We have everything we need to root the box, so let's do this. Let's restart the music because that's just died. So of the two vulnerabilities that are immediately available, we will work through the unquoted service paths for one simple reason: getting a reverse shell back is very easy, even with Defender in play. The exploits available to us manipulate the privilege we found. Would need to be custom compiled and obfuscated in order for us to be useful to us. However, with the unquoted service path, there is only one very small wrapper program that activates the Netcat binary that we already have on the target. To put it another way, we just need to write a small executable that executes a system command, activating Netcat and sending us a reverse shell as the owner of the service. Ideally, we would write a full C# service file that would integrate seamlessly with the Windows Service Management System. While this is perfectly possible and by far the preferred option, for the sake of simplicity, we'll stick to just creating a standalone executable. It's worth noting that this technique is effective at bypassing the antivirus software on the target. However, as in an enterprise situation, there's a good chance it would be picked up by an intrusion detection system. In this scenario, we'll be looking for a more sophisticated, if similar, solution. Ideally, we'll be using Virtual Studio here. If you happen to have a Windows host and are familiar with Studio, then feel free to use it. I do, but I'm not using it for that. The teaching content will work with the mono.net compiler for Linux. This can be easily installed on Kali and will allow us to compile C# executables to run on Windows targets. C#. The same code will work just fine if compiled in Windows in Visual Studio. So we need mono, so let's grab that. I need my box. Let's stop that. So let's install that. Then we need to create a file called wrapper.cs in my favourite text editor. First thing we need to do is add our imports. We can actually do this in here. So let's. Don't need my POC.
I hate how Kali just pushes updates without testing shit.
Thank you for the
Metasploit is
follow.
wonky now.
When did they break that? Don't worry, I'm just eating chocolate. So we don't care about that. Save my notes. New file. Save it in Wreath, and it's going to be called
It's a Ruby thing. Probably doesn't play nice with Ruby 3.
okay. So the trick is to just never update. So we need to use our imports. These allow us to use predefined code from other namespaces, giving us access to some basic functions. This allows us to start new processes, e.g. execute Netcat. Then we need to initialize the namespace and class for the program. So we can now write the code that will call Netcat. This goes inside the main function, not here surprisingly. First we'll create a new process as well as a process start info object to set the parameters of the process. Why did that? Make sure to replace NC username with your own Netcat one. Yep. So msec. .50.91.117. We're going to need another thing, aren't we? So let's go 445. It's going to be 100. Wreath again. So 4445. With the objects created, we can now configure the process to not only create its own GUI window when starting. So let's check that in. And then finally we can attach the process start info object to the process and start the process. There we go. So let's check it looks okay. So let's save that, and then on this box, cd should have the wrapper CS. There we go. So then we can do MCS wrapper CS. Now we've got a wrapper exe. So we compiled it. Let's check my network's still up. Another hour, please. Transfer wrapper.exe file to the target, or to spice things up a bit, let's use an in-packet SMB server rather than our usual web server. If you prefer to use the web server and curl, then you are welcome to do so. I can't be asked to do that stuff. I've got in-packet already. Just adding the share. Let's Listener on
Curl is
report.
easier.
Yeah, I was just going to do curl. Not messing around with in packet. Right, so here we need to just do start a Python server again. Where do we want this to go? I guess I can just curl 10, 15, 91, 172. .exe. Put it to. Oh fuck! Where's all that gone? Let's do it this way. Windows. Output. Couldn't resolve host.
It needs to be the same name, I think.
Yeah, possibly. Let's just rename it. Not resolve.
Nightbot says,
10 subscribers to go until we reach
can
the goal
connect.
of 15 and unlock new emote slots.
Oh,
Use those
just fucking
Prime
killed
subs
the
if
thing.
you have them.
Balls! Just killed myself. Alright, let's do that again.
Ted_918 says,
User wrap.
That's the one we want. Oh yeah, choose one. Actually, I don't get why that doesn't work. Like why it won't upload it to the right place. We've got curl, so curl. I can ping myself, so that should work. Did that work? See. No. Bastard. Bastard. Just doesn't like those extra backticks. Port number ended with /. Maybe it just wants me to use a port number. So we can add a port. It's not an issue. I bet it works from this. No, what the fuck? We upload it before, or is it? Surely that Netcat MSAC should be there. Very odd. It's just, yeah, it's definitely fetching it. Try that, like a dumb version. quotes. Did not resolve. Why is it? What's the output? Am I doing the right one? Remote name. No, I don't want remote name. I want lowercase a. Twat. Twat. Alright. Right, let's try it again without being a moron. I don't get why it doesn't list the directory. That's absolutely where it's putting it. What's the show everything? I'm just going to assume it's uploaded. Let's just try and run it. So let's get our PowerShell thing again. And then instead of Netcat, we're just going to run the wrapper. So that's not right, is it? It should be... It must still be in the uploads directory. Like, let's say we're in HDocs. HT.doc is literally fucking there. Yeah, look, they're all going to upload, so that's why we're running from here. So can we just close the windows, command line copy. Or move, I don't really care. Source destination. So MSEX. See. Overwrite. So it is there. Just can't view it. Windows. Oh, idiot. Yeah, there's nothing in it. It's just bizarre. Weird. Right, that's done something. I'm Still fucking Thomas. Is that it though? Just unquoted service path vulnerability occurred due to a very interesting aspect of how Windows looks with files. This means that if we create a file called directory.exe in the root directory, we can trick Windows into executing a file instead. Okay, directory 1, directory 2, executable. So, take a look at the actual path of our vulnerability service. There are technically 3 places we could add our program here. We could put it in the root directory and call it program.exe. This is very unlikely to work. We could put it in program, call it system.exe, once again unlikely to work. We could put it in System Explorer and call it System.exe. This one will work. Remember that we check permissions. Okay, so I haven't actually done my privesc yet. Before blindly copying your wrapper, close that one because it's basically doing fuck all. Check to make sure that it's another user isn't performing this kind of exploit. If you see a file called system.exe in the output, then please wait a few minutes until it disappears. If it's not already an exploit in the directory, then it's time to root this thing. Copy your wrapper from temp. Which means that should be like that, and then yeah, just don't think it likes those temp strings. Yeah, because it's going to the wrong place. It's not doing the Windows temp. We omit that and stick that in instead. Access is denied. Sick. Take the extra backticks out. Why doesn't that work? Try and get into program files. Just take the quotes out, see if that makes any odds. No, definitely preferred the other one. Oh, this is fucking dumb. Why? Unless I'm missing something here, like user allow full control. Won't let me fucking copy anything. I just copy it from the uploads folder. See where that was again. Alright, that works. So it's just a fucking temp directory that's being a knob. Alright, so now we've got a system.exe. We can try stopping the service. Restart it. I mean, I'm not getting anything back. Copied, haven't I? Let's just check my things running correct. Yeah, 445, the right IP. Our exploit is in place. We have two options. Waiting blindly for it to work, which is what we're currently doing. Just says start pending. Nothing coming back. Tempted to just create a new wrapper with the this uploads thing instead of the temp. 1050 91 170, so that should be right. Restart my Python server. Guess we know that's not doing jack shit, so that can go back in. So we've got a new compiled binary. Let's try and start again. That's looking better. This one should fail to start. Don't have any connection back though. Did I copy the right thing? NCMs. Let's just delete my thing so that other people can use it. resources. Copy. Stop. Four, 5. It's definitely going out through 445. Let's look back through this shitty documentation to see what didn't work. Let's delete piece of shit exe and let's delete exe. Let's delete wrapper msec exe. MCS wrapper. Sure, I can just copy it directly up to here as well. If I do let's call it system. And I can just grab it and chuck it. Straight in there. Just listen to 446 a second and then where's the Netcat one we did with? Let's try and get it from here. I just don't get that. I got the listener here. My system exe is there. My uploads are there. Ping 1591 117. Contact it. Anything potentially is the port. So we'd redid it for that. Let's recompile it. Got a new wrapper, a new system. Python it, stop you can listen on 443. Right, let's do one of these at the bottom. Yeah, I did. Alright, so let's just... Okay, so that's gone. It's already been cleaned up. So let's... try and upload my file. Just put it there, and then let's try and stop the services again. Failed to start again. Got jack shit come back. Cannot find the file specified.
Thank you for the follow.
Thank you for the follow. Ling10501. Load it again. The only thing I can, like, if it can't read that, but we tried the other one as well. So that's definitely accessible. Just fucking cancelled it again. Oh, finally. So didn't like the port. Why doesn't it fucking say this in the notes? Like, you have to use this one port and only this one port.
Crumbs_ says.
Feels good to get a shell.
Yeah. Everything else so far, it's been like, pick a shell that's over the 15,000 range so that you're not messing with anyone else. And then this one task, it's like, no, actually, you've got to use this one port because it's the only one that's open. Good luck. Like, just that one note would be great. Right, so we've got root. Notice we got turn this off.
443 and 53 are often open, I guess. But yeah, I get your point.
Yeah. So we get a message telling us that we failed to start. It's because the wrapper isn't loaded. It's not a real Windows service file. Our executable still gets executed, but as far as Windows is concerned, it failed to start. Yeah. So there's only one thing left to do here. Let's clean up after ourselves, deleting the wrapper. So let's go back here. No, not there. You gotta go. Oh, they give you the code. That's sweet. Let's do that. So we delete it and then start the service. So other people can hack. Clearing up the exploits is a good habit to get into. There's also the added bonus of being courteous to other users of the box. Note, deleting the wrapper and starting the service did not destroy the system shell. Yes. Bonus question. Research how to write a real Windows service executable in C. Try to create a wrapper, even a full reverse shell, that doesn't cause the SC start command to error out. Okay, we won't do that. Code here may help, but do not run this as is because it will create a new user with a known password. Okay, that's part of the bonus question. Right, what are we exfiltrating now that we've got root on this? So it's something which should never be considered without explicit prior consent. Generally speaking, most external engagements will prohibit taking data from a compromised system. However, it's worth bearing in mind.
H8 Handles says.
Don't nobody have time for that.
Yeah, no, I've spent too long on this already. I'll come back and do it if I need to. So the goal, yeah, okay, because we got. I don't care about this. I want to know what I'm stealing. If FTP is good protocol to use, then exfiltrating data in a modern network. I guess. Still good options, so let's go with yes. Nay, okay.
Nay.
Maybe I should read it. Is that just because it can get picked up? A real-world attacker will exfiltrate as quietly as possible. Okay, so that's why. So just you flag up. For what reason is HTTPS preferred over HTTP? Is it just because it's encrypted? Yeah. Encrypton.
Good for modern. WebLink isn't typically running if it is heavily watched.
So let's put this into practice. We need some way to prove that we've compromised his PC. We could leave a note on his desktop. We could rearrange all of his icons into the shape of a dick. There's no way we'll get Mimikatz past Defender. We have system access. We could technically just disable Defender. And let's try to do this with as little destructiveness as possible. So we can grab files containing password hashes, pass them back to our attack machine, dump the hashes locally. On Linux this is just a case of grabbing etc shadow. On Windows it's more complex. Local user hashes are stored in the registry while the computer is running, especially HKey, local machine SAM hive. It can also be found here, however it should not be readable while it's running. To dump the hashes locally we need to save the SAM hive. This saves the hive in a file called sam.back in the current directory. Dumping the SAM isn't enough though, we need the system hive which contains the boot key for the machine. With both hives dumped we can exfiltrate them back to our attack machine, dump the hashes out of sight. It's up to you how you choose to exfiltrate the files, given that this is a home network with no monitoring in place, an SMB server is recommended. Connect to your SMB server using the system reverse shell. Okay, so this is why they got you to do SMB earlier. You can now either save the files directly to your own drive or move to the attack machine you created. Going to give you any other options or not? Doesn't look like it. I'm just going to get you to do InPacket again anyway, so we might as well spin up InPacket. Again, what I wish it would say, you know, when it gives you the option to do the SMB service earlier that we were farting around with. So like right up here, no. All of this bit, like if it said we're going to use this again later so you might as well use it, then you would, but it said no, you can use this or another method, so we did the other method. Retarded. Right, I've got InPacket already, so we can see my downloads. Oh yeah, back in. We've got this already. In the attack box, we can now start a temporary SMB server. So let's just do this. Guess we can just use the built-in one as well. Use a password, secure password. Now in our reverse shell, we can just use this command to authenticate. Yeah, I've got that. Let's go back again, is it? No, okay. $10, $50, $91, $117. Share user. Right, so that should do. So we've done that, and then listen. Let's skip there. The Final Fantasy ones always seem to get DMCA claims, so let's just skip those entirely. Right, so to prevent errors, we should disconnect for it for the time being, which we're not going to do. So we can go. So let's dump these out. Share, wasn't it, I think? Let's get the system back. System look back 10, 50, 91, 172. Share system. You may encounter an error when reconnecting. This is okay. That's right. So we bypassed this bit by not doing it earlier, I guess. So that's not too bad. Just get the disconnection thing. I can't remember what it was. That's it. Net use 10 D91 172 share/del. Why didn't that work? Oh, net user. So we deleted the share. Right, so then back on our box, we can stop that. There we go, and dump the secrets out. So what's the admin NT hash? Oh, no, that one. We now have completed everything we set out to accomplish, demonstrating that Wreath's network is vulnerable. Take the chance to go through the network, clean up after yourself. Aside from being courteous to other users of the network, there's also something you should do in real life. Remove all the tools, shells, payloads, accounts, and any other remnants you left behind. This is like the worst bit, because I've left so much shit everywhere. It's already cleaned it up. Oh no, I moved it, of course, yeah, so that I don't have to do anything on this one. Same for this one I do, so what have we got in LS, in uploads? I just get rid of it all. Oh, there we go. That was easy. And then C. I have to do it from this one because we can't CD C. Windows 10. Hey, well now I can finally see my shitty payloads that I dumped here, so we can go NC sec exe Why did that not work? I guess I can't get rid of MSec Netcat because I'm currently using it. Yeah, it's probably in use. But yeah, we've done that one. Oh, I forgot on this box. Got anything on this one other than chisel, whatever that was. Windows temp, so cd. Yeah, so my chisel, so we'll leave that just in case it gets me to do anything else. Debrief. So we started this assignment with 3 targets, 1 Linux, 2 Windows. All 3 have been compromised. Hopefully you've been taking notes and now about to start writing the report on the topic. If you're not familiar with pen test reports, following tasks may come in handy. Offensive Security have published an example 10 pen test report here. The whole community curated repository of public reports is here. First up is the Exec Summary. I can tell you right now I'm not going to write a report on this. This feels too much like work. So, with your report written and proofread, so write a report or just read the information. Yes, we should just be reading the information. You can keep the report for your own records. I mean, I'm going to write up the RUM later, so that's fine. In the real world, a section of pre-engagement meetings between the client and pen testing company. Yeah. Considering the following brief to be a report handling procedure for this assignment, reports should be written in English, submitted as PDFs hosted on GitHub, Google Drive, or somewhere else to be viewed in a browser with no download required. Reports should not contain answers to questions as far as possible. Host name is fine. Password or password hashes are not. They should be encouraged to write in these formats. The penetration testing report, write-up submitting in other formats will not be accepted to the room. If you want to do a video walkthrough or video of the network, then this could be linked at the end of an otherwise complete PDF report. But yeah, that was the room. That was a lot more effort than it needed to be. So many things went wrong. Who's asking to reset it? It works fine. Alright, unable to generate link. There we go. Cool. Alright, I'm gonna raid someone else and then I'm gonna carry on but playing some video games, so if you want to stick around, hopefully Stairs is still around. He hasn't popped in the chat yet, so but yeah, we'll be playing some more Satisfactory with Stairs the Trash Man.
Oh look, chalk. A for apple, B for bat, C for cat, D for dick.
Who have we got on? Hate Handles is on. Popped in earlier, so we'll give him a raid. Send everyone his way. have started. Good. Cool. Thank you again, everyone, for sticking around. Thanks, Theo, for the raid. Thank you for the follows. And yeah, if you stick around, we'll be playing later on as well. So a bit more casual than trying to figure out how to hack stuff. It'd just be sort of breaking things in Satisfactory. So yeah, hopefully see you all in a bit. If not, enjoy Hate Handle stream, and I'll see you later. Thanks a lot.